Welcome back to the Anker SOLIX channel. Today we're taking a closer look at what makes the E10 different. This is not just a power system you plug in and forget. It's got memorable engineering from the inside out for durability, safety, and long-term outdoor use with incredible features to keep it silent while it's running. So what makes it so infinite, powerful, and smart? Let's tear down this power module and find out. Let's start with what you see on the outside, because the housing itself tells you a lot about how the system is built, and it actually helps it operate. The front panel is made from a zinc magnesium aluminum alloy. Now, compared to plastic housings commonly used in portable power stations, this material offers significantly higher durability and corrosion resistance. It's built to withstand salt spray, humidity, and long-term exposure to harsh outdoor conditions. The rear panel uses aluminum silicon 8, an aluminum silicon alloy with a thick wall design. This provides excellent structural rigidity and resistance to shock and deformation. Even under heavy loads or vibration, it stays stable. On top of the metal housing, the E10 is finished with an F1 grade UV-resistant coating that prevents fading or degradation in direct sunlight. After years outside, it will still look like new. The E10 is rated IP66 and NEMA 4, and it's UL 954-0A certified. What does that mean? Well, it means it's been tested against extreme conditions, including heavy rain, snow, high heat, and dust. This is industrial grade protection designed for home energy systems with no leakage risk to keep the insides dry. Now let's move on to the ports. Every port on the E10 is plug and play, fully NEMA 4 and IP66 waterproof. Notice the black sealing strip at each port base? The recessed design prevents water pooling or seeping inside. Each connector has an orange waterproof gasket, forming a compression seal when plugged in. Ports and connectors together create double layer protection against water intrusion. Now let's take a look at something I'm really excited about, and it happens on the back. We have the heat dissipation fins. This is the primary cooling method for the E10, and these aluminum fins passively release heat, so there's no constant fan noise. Heat just flows out naturally with no moving parts. Now there is a tiny internal fan, but it only kicks in above 176 degrees Fahrenheit, and its job is to gently disrupt airflow, not actively cool. So even at 7.6 kilowatts of continuous output or 10 kilowatts of turbo mode for 90 minutes, it stays almost completely silent, ensuring you have power without thinking about it. Now that we've covered all of the external features of the Anker SOLIX E10, let's open this up and get into the teardown and show you where the magic happens. Now that we've got the screws removed that keep our two shells of this unit together, we're gonna go ahead and separate these two parts and take a look at what's on the inside. All right, look at that. Now I'm gonna just disconnect the cable to the screen. Now that we're inside, let's follow the power flow inside the E10 from right to left. We have three zones: DC inputs here on the right, the processing core in the middle, and the AC ports on the left. Starting on the right, we have all the DC inputs, the solar input, DC generator, and battery feeding DC power into the system. Over here on the left, we've got all the AC ports, the on-grid port that handles bidirectional AC, there's the off-grid AC output port, and the AC input for generators or wall charging. Basically, this is where the E10 hooks up to your power dock, smart inlet box, AC generator, and the grid. Now in the middle of the E10 is the processing core of the operation. The DC bus acts like the main power highway, and the filter and inverter sections here are the workers that transform that power. Think of it like a factory. The DC bus is the conveyor belt moving the energy where it's needed, while the layers do all the heavy lifting to get it into the right form like workers do. Now that we have a general understanding of the layout of the E10, let's take a look about how power flows in both directions, going from DC to AC and AC to DC. When powering your home during discharge, DC from the battery flows into the DC bus here. It goes through the inverter layer to become AC power. Then it passes the filter layer for a clean sine wave output and comes out of the AC ports. From there, it goes through the power dock or smart inlet box to power your home. Clean, stable, and just like grid power. Now let's take it back the other way and see what happens when we're charging and the flow reverses. AC enters through the ports, it passes the filter and inverter layers, where it then reaches the DC bus and charges the battery. It's the same workers, just doing a different job. Let's take a look at one of the very special features that the E10 has when it's charging and how it bypasses one of the steps on the pathway. Here's the key difference when charging the E10 using the Smart Generator 5500 compared to a regular AC generator. The Smart Generator 5500 converts AC into stable 400 volt DC power itself. Think of it like the battery feeding the power module directly. This DC goes straight into the E10's DC bus, then into the battery. Now for a regular AC generator, using the bypass input, the power has to go through the AC input, pass through the filter and inverter layers, and only then can it reach the DC bus. Now along the way, energy will be lost and it's not as efficient. Because we can charge directly off of DC from the generator, we save a step and improve our efficiency. Now before we dive into the technical highlights or meet the brain of the E10, which is the MCU or microcontroller unit, we've got some screws to remove and dive a little bit deeper into the E10. Now let's remove these OT terminals on the M2 board so we can get a little bit deeper into the E10. Wow, as we get in here, you can see this is a really solid structure. I mean, the weight of the heat sinks and everything, and all of these fasteners and zip ties really make sure that this is going to be vibration resistant and a really durable, long-lasting system. Now that we have our E10 fully disassembled, let's dive in and meet the MCU, which is the brain of the operation. It's a microcontroller unit. It's a command center that coordinates everything: the LRA startup power, turbo mode, battery charging, and solar optimization. All of that optimal performance, it's this chip working in real time. Speaking of turbo mode, let's take a look at the inverter layer of the E10. So how does it deliver 10 kilowatts of turbo mode power for 90 minutes? Well, it starts right here in the inverter layer with the IGBT modules. These are insulated gate bipolar transistors, premium grade components designed for high power DC to AC conversion. Now, most systems overheat after a few seconds, but the E10's inverter layer is built differently. High power density and a compact footprint, plus smart thermal design. Each critical component has its own heat sink and thermal pathway. That, combined with heat fins outside, internal and external cooling, work together seamlessly. The result? It's 10 kilowatts of turbo mode power for 90 minutes, not seconds, not a brief spike, sustained high power for real-world household demands without overheating, without throttling back, thanks to the E10's impressive revolutionary thermal management. Basically, each transistor has its own dedicated heatsink built into the highly conductive aluminum case. While we're on the subject of high power, let's take a look at another key ingredient in the E10's high power capabilities. This is the LRA inductor bank. Now, if you wonder how the E10 powers heavy appliances like central AC, it's all thanks to this inductor bank. Here's the clever part. When the E10 powers on, it pre-charges these inductors. Then whenever your AC compressor demands a massive surge of current, the bank releases it instantly. Starting a central AC draws far more current than normal operation, so without this energy reserve, the system would trip. With the LRA inductor bank, the E10 delivers 37.2 kilowatts of startup power, and that's enough to effortlessly kickstart even a 5-ton central AC unit. Now let's move across the board and take a look at the DC to DC converter and how it's used for independent battery management. Now over here is a part of the DC to DC converter system. It transforms the DC current into a stable higher voltage DC output. You can see a small portion of the circuitry here in the power module. But the main DC to DC converter lives inside each battery module, managing voltage between the individual batteries and the DC bus. Now the battery module is too dangerous to tear down for this video. High voltage, sealed cells, you know. So here's a reference photo showing the internal DC to DC converter inside the battery pack. The DC to DC steps the battery voltage up to a stable 400 volts going into the power module and keeps it stable coming out when charging. Now, why does this matter? Well, independent battery management. In most systems, batteries connect straight to the inverter. When the weakest battery fills or empties, the whole system stops. It's the barrel theory. Your total capacity is limited by your worst performing battery. Now, the E10 is different. Each battery converts its own voltage to 400 volts through its DC to DC circuit. Every battery charges or discharges independently, so no single weak battery holds the others back. The result? Maximum efficiency. Every watt hour counts. Now that's smart battery management. So that's what's inside the Anker SOLIX E10. Industrial grade construction with zinc magnesium aluminum housing, IP66 waterproof protection, passive cooling that keeps it silent, premium IGBT modules for sustained 10 kilowatts of turbo mode, LRA inductor banks for massive startup power, and independent DC to DC converters for intelligent battery management. Now this isn't just a power system. It's a precisely engineered piece of equipment designed to deliver infinite backup power in the harshest conditions year after year. Now, if this teardown showed you why the E10 is engineered differently, make sure to subscribe to the Anker SOLIX YouTube channel and stay tuned for more videos about the E10 and the technology that powers your energy independence. Drop a comment below and let us know which engineering feature impressed you the most. The silent cooling, the turbo mode inverter, the independent battery management, or a dedicated heat sink for every transistor. Well, we'll see you next time on the Anker SOLIX channel. Anker SOLIX, the only backup power you need.